everyone, I'm Elisa. We're back. We're doing the circulatory system, blood in particular. This is part 10 of our little 10-minute-ish video series. So this is the ABO blood types, or the blood groups, however you want to call it. And just kind of the basics of it, just to get you kind of introduced. Okay, so there are a lot of blood types. There are actually way more than just these blood types, but I kind of wanted to get you used to the idea. And so just the ones that we're talking about here are the ones where somebody says like, oh, I'm type B, I'm type A, oh, I'm type A, B, type O, those ones. And just to start off, let's be clear about what O is. It's not really type O. They didn't really go A, B, and then not remember C. Blood type O means not, right? So it means something that is without something. And so what that means is, as you can see, like the ABO blood group is referring to these surface proteins, right? So on the surface of all cells, this is just like one, but really they have like probably thousands, if not tens of thousands, who knows? Well, I guess blood researchers know, but I wasn't a blood researcher, so this isn't my wheelhouse, guys, sorry. Anyway, so what happens is these little like proteins that sit on the outside of the blood cell proper, they touch other cells, right? And other cells use them to identify maybe self or someone who's different from themselves. Okay, so they're a signal. They're kind of like an ID card. They're like like a name tag, like a passport. Okay, so let's get started. Okay. So we're going to talk about, explain what the ABO blood group is. Then we always throw in the rhesus factor, which is just RH, right? So rhesus is like a monkey, and we share this factor with them. It's also an external blood protein thing, which is really important when it comes to pregnancy. And it also, we'll talk a little bit about the history of transfusion and why the blood groups are super important for that. Also, transplants, right? They're actually more to consider for transplants. We'll talk about how they are useful. We'll also talk about some of the effects of incompatibility, right? And we'll talk about the relationship of the mother and fetus and some of that incompatibility as well. So blood types and transfusion compatibility are generally between red blood cells and plasma protein, generally, okay? So it has to do with clotting mainly. And so Carl Landsteiner discovered the blood types A, B, and not, right, or O, in about like 120 some odd years ago. And finally, like after 30 years, got the Nobel Prize. So yay, Carl. Blood types are based on these interactions between what we call an antigen and an antibody, right? So an antigen is like this molecule that's out there just, minding its own business. You go, hi. And then an antibody is something that says, oh my gosh, look at that. I think I was born to bind to you. And then they just do, right? And so that's an antibody and that's an antigen in a nutshell. Okay, antigens are actually complex molecules on the surface of a cell. They activate an immune response, or they also allow other cells to come by. Here's a cell, right? And identify individuals, right? Like as, here's self, right, for this cell. Like, and then another cell, especially an immune cell, a big white blood cell, is coming by, and they're going to want to make sure that what they feel is, self, because then they can identify that, you're okay, yourself. But anyway, so when we're talking about blood groups, we're looking, kind of down the stream of that quite a bit. So they're genetically identical or unique to each individual, not cell, like individual person, for example. And again, they help distinguish self from like foreign matter. So here's one that's like, hey, we're friends. I know who you are. But like, here's another one, right? Let's say this is like type A, right, blood cell. This is like a type A white blood cell from person A. And then they get a transfusion, right? And they get a transfusion from somebody who's type B, right? And the surface antigens for type B are a little different shaped. What's going to happen is we're still going to have these antibodies that are expecting kind of like a different shape, in this case like a triangle shape, not a circle shape, and they're going to go, oh no, this is bad news, you're an invader, right? And they're going to signal for the degradation of that individual. So it's really important because we need to keep foreign matter such as bacteria and other cells that could be damaging the body out of there. So it's like, kind of basics of it. Foreign antigens generate that immune response, right? So they signal that something bad is happening, some foreign invader is here, so we better respond. And like the ability of agglutinogens, right? Let's like agglutination means like they're going to start sticking to each other, right? I don't know if you guys ever watched The Incredibles, it's this movie, and it's the first one, and Mr. Incredible finally got into, like Syndrome's lair, and he went up to the Chronos machine, and he's like, oh, he figured out all these things, and then all of a sudden, like the sensors saw him, and so he's like running down the hallway, like this little bridge, and then all these little sticky balls start like getting thrown from wherever to him, and he's like, oh no, and they stick to him and they make it so he can't move, right? Agglutination's sort of like that. Like they are this big little proteins and elements that start sticking together, sticking to something, and they kind of immobilize it, right? And so, right, so we're using these surface antigens, right? So this is the blood type. So we're looking at their ID cards. You can have an A ID card, a B ID card, an O ID card, or an AB ID card, essentially in humans. So a person with type A presents a type A antigen. A person with type B has a type B, right? So you just imagine like here's a little cell, and here's their type A, and here's a white blood cell, and they're like, ooh, what kind do you have? And then here's a person over here, and I'm type B, so my antigens, so like that. What's interesting though about an AB person is they do this. They can make both A and B all day. They can show either ID, so it's kind of nice. The type O person generally doesn't have an antigen to show, and so they kind of get under the radar that way. And type AB is the rarest combination, and type O is one of the most common ones. Okay, and so as you can see here, the type O doesn't have that like little confirmation in this representation that would signal, that this is something different. Here's a type B, as you can see, here's a B here, right? Here's that type A, as you can see, here's the A here and the AB. Okay. So the agglutination of erythrocytes, so those like, we're going to get all these little proteins to stick to a erythrocyte, right? Make a clot. The proteins of these antibodies are secreted in the plasma cells. Okay, so they're part of the immune response for foreign matter. So, I mean, it sticks to a bacteria, it sticks to a virus, it sticks to anything that's just not the individual's own cells. It's a protective thing, right? So it binds them, and then it also marks them for destruction, right? So it forms this complex where they stick to each other, right? So remember we talked about someone with this antibody. There's the antigen, and then the antibody just like sticks to them and says, over here, everyone, it's over here. Okay, so this is like antigen, antibody, and when they stick together, they complex. That's what that means. And so it causes like these red blood cells to obviously get clumpy, right? And that's because of those agglutinins, right, which are just sticking all over to them. They just make them thick and heavy. And so those are the antibodies in the plasma that cause that transfusion mismatch. And so that's why some transfusions work, right? Ones that don't clump, they don't clump. But if we transfuse a type A blood into a type B person, they are going to clump, just like up here, get blood clots and then go through hemolysis, and it's pretty tragic stuff. Okay, so I'm going to continue on in another little video, but that was just kind of enough for now. So just like marinate on the idea of there being a couple of different blood groups, ABO, marinate on the idea of agglutination, antibodies, and antigens. And in that case, we will see you in the next video. All right, I hope you're having a great day.